Eric Masaba is going to tell us about how numbers are pictures. Welcome to the stage, Eric.
Good evening. This is going to be a really kind of a strange one. Did you realize that every number is actually a picture and all the pictures exist? That means everything you're going to do, probably have done, is already searchable in some index somewhere. It sounds crazy, but theoretically a big enough computer or cluster of computers could find all those images of you being naked, you doing stuff with Donald Trump, whatever. We could even tag them and put them in your Facebook, Instagram, or Snapchat feeds. It sounds completely nuts, so let me explain a bit more. Everything is a number. Every book ever written is a number. The set of all books ever written is a number. Movies, pictures, anything you store on your computer is stored as a number. Back in the day, on computers, this is what you had to do to create images. You took a grid and then you drew the thing and then you had to convert them into numbers, and that's how they're stored. It was actually very visceral in those days. It was actually exactly that way. The number of images you could have for a certain size is in this ratio 2 to the n. If you've only got 1 bit, a 1 by 1 pixel, you've only got 2 images. If you've got 8 bits, you can have 256 images. If you've got 64 bits, 2 to the power of 64. Any image starts that way, and any image can be shown as a raster image that way. Raster means that when you scale it, it doesn't get any more fine. It will look blocky. When you want more colors, you have to increase the bit width. So if you wanted 8-bit color, you need 3 times as many bits. It's just to do that 2 to the power n. So that's the basic idea. And I thought about 30 years ago, when somebody said this to me, I thought, that's really odd. How can that be the case? Well, we see this anyway with this thing called a Mandelbrot set, which actually is a simple mathematical function which you can keep zooming in and getting more detail. Apparently it never repeats. And that's just from one mathematical function. Back in the 30s, the Germans thought that if they created a big enough code machine with enough variations, you'd never be able to break the code. And this was Enigma. Actually, that's a Lorentz machine, which had even more dials. But with Enigma, they'd have 15 billion combinations. That's 15 trillion. Snowden says if you want to secure yourself against NSA snooping, get password, assuming the NSA can guess 1 trillion guesses a second, which means they'd break Enigma in literally 15 seconds or less. So why is this useful and why should we worry? Well, you can solve a lot of these what are called MP hard problems, which are very difficult problems in mathematics, which require lots of combinations, using those brute force methods, okay? You can see the solution set and then find similar candidates. So if we wanted to start with a picture of anyone, like Adrian, for example, doing something with Donald Trump, we could just start with the 2 of them and have the computer cluster start to look for those images, and we would find them. They exist somewhere. So now how do you know if anything is actually true? Just because you saw a picture, it doesn't necessarily mean it happened. Computing power is getting bigger and bigger. We can do all sorts of things. And as we move forward, we're going to see more and more fakery. So what are the implications of this? You could have an image which could be proved to really exist, which could set whatever gender you wanted. We can fake anything now. And fake is no different to true, because all the images exist already. You can mathematically do it. What can we do to mitigate this in the future? I think the ultimate thing is you've always got to try and get more than one source, and you've always got to be aware that what we can do with computers can be used for good as well as evil. There was a bit there which I pointed out that numbers are evil. Numbers are just numbers, yes, but they are documents, they are pictures, they're images. This is some high school kids who tied 8 world records for solving a version of the traveling salesman problem, which 20 years ago would have been the most unbelievable feat. They did it probably in an afternoon as a science project. So that's just to recap. All images already are there. They already exist. We've all got images of us doing something, being naked, something embarrassing. It's a triviality now for computer clusters to search that image space. Even right now, the numbers are huge and big. It can be done. What will we do in the future to know who is telling the truth? We can have any image we want, and that's going to become increasingly the case. So please do think about that. will we know what's real? Will we be able to know the difference between actual real images and images which we've just literally created from a computer? Thank you very much.